Hello everyone, can you hear me?
Yes, I can hear you.
Okay, great. Well, hi everyone, welcome to the Space Awareness webinar series. My name is Teodora Iwan, and I am a member of the Space Awareness team at European Schoolnet. I will be moderating the session today, and with me is my colleague Adina Nisto, who will provide technical support through the chat. You can see her with the Scientix account, and you also heard her earlier talking to Vincent and setting up all the technicalities. So our presenter for the session is Vincent Verhoeven, educator with the UGent Observatory Armand Pien from Belgium, and he will talk about navigation through the ages and using astronomical instruments. Now, the presentation will last about 45 minutes, and after that, we will dedicate about 15 minutes to your questions. In case you encounter any technical problem during the presentation, please write to Adina. Remember, she's with the Scientix account in the chat, and she will support you through it. You can find the chat tab on the right side of the screen. Also, very important, please remember to turn off your microphone and camera during the talk. You can also use the chat to share comments or suggestions with the other participants and to post questions for the final session. To share with everybody, please select the option Everyone in the recipient menu. Otherwise, we risk missing your questions. And now, I give the floor to Vincent, our guest for today. Welcome, Vincent. Thank you for being here, and good luck.
Yes, hi to everyone. I'm Vincent. I'm at the observatory. Well, if you don't believe me, I'm just going to upscale the cam, and you see this magnificent telescope that at the end of the talk will gather all the information from during the talk to see what navigation through the ages has come to in the 19th century, because then a lot of things that have been invented during the ages can be seen on this magnificent telescope of 1880. Well, since I can only use one camera, I hope you can see me clearly, and I hope you will see the presentation as well clearly. So I trust on that you will see it. I'm Vincent. I'm from Ghent. Well, I'm working in Ghent. Originally, I'm from Antwerp, but we're in Belgium. And here I'm in the cupola, which is from 1903, but the telescope behind me is from 1880. Well, we start. We're going to look at several instruments chronologically, and we will start with the simplest instrument that you can see at the left upper corner, which is just a sundial with some stones and sand and a stick. And it's actually remarkable that from the shadow, from the stick, if you know how long the shadow is and you know the angle of the sun towards the horizon, then you actually know how long the stick is, which is very in many cases they use it to measure buildings or height of buildings if they cannot climb it or measure it in the height by hand. Now, during the talk, we're going to talk a lot about angles. Could be that some of you didn't learn about angles anyhow, but it's just the impression on how the techniques are used is more important than, of course, the details. A sundial, why do I start with the sundial? Everyone knows a sundial. Everyone can be a sundial by itself during the day if the sun is shining. And if you look at the sundial, you will see a lot of things that you can orientate on. Like if you're in the northern hemisphere, like the Europeans, like we, and most of you, you can see that the shadow is actually casted towards the upper part of the picture. And we know that the sun is highest around the equator. That's the middle part of the Earth that we'll see later. And so we can extrapolate something from this picture. We can see something from this picture. We can know that actually the sun is shining in the south, and that the shadow is actually casting its shadow. The stick is casting its shadow towards the north. So it's easy to orientate. And the best way to orientate is actually to wait until the shadow is smallest. So now the shadow is apparently not smallest, should be smallest when it's directly upward stick, and then it will be smallest when it is at noon, and then you will see that that is directly pointed to the south. Well, that's just an intermezzo, just to start on angles. Next, you will see an astrolabe, which is much more complex if you look at it. You see a lot of artwork as well. It was not only an instrument for navigation, but it was actually also a prestigious instrument, an instrument to show that you had knowledge of the world and that you had also money, because it's a very expensive instrument to make. But it's like a very special instrument that we will look at in detail later, because it's like a small computer, like the first computer that you can wear beside you everywhere you go. You can actually compare it with a ancient smartphone, but later on that. Then next to it, you will see a navigational instruments for on boats. It's a sextant with a small telescope on it. And you will also see there is a compass near it. It's a bit fantasy art, but later on we'll see some real stuff. Underneath, in the middle, you will see the big telescope that's behind me. There, everything will come together. So I will leave that for the end. Now you will also see the armillary sphere. At the left hand side in the middle, you see, well, if I hold it, maybe it's this one. You will see it in detail in the picture. It has a lot of rings, and all these rings, they actually are different places in the heavens, so in the sky. And it's very important to understand these rings in order to understand how navigation works, especially in the beginning. Everything revolves around the Earth and the Sun when we talk about navigation. Then at the right hand side, we see a sea clock. This is a very special clock. It's not just a clock, it's a clock without a pendulum, because a pendulum was really difficult to use on boats, because boats, because of the waves, they go up and down, and so the pendulum, which is going in different directions. I don't have a picture of it, so sorry for that. But this is a special clock that could be brought on boats, but was invented really late in the history of navigation. And then in the end, I will also talk about modern navigation. Like if you see at the left corner, the down corner, you will see it's a special device. It's a star tracker from space probes to navigate and to orientate themselves towards the stars. Yeah. I will also talk about satellites, but there's no picture on this yet. It will be later. And then you will see on the right-hand side, you will see a disk. It's a special disk, which was actually, if you look at the webcam, maybe you will see it. It's like a space probe that passed by several gas giants. All the gas giants, Voyager 2 and 1. Voyager 2 passed all the gas giants, and on this space probe there is a disk, and this disk, well, was actually specially developed for if one day, maybe when humans are not there anymore, not to alarm you, but very, very late in the future, maybe another life form will, intelligent life form will find this disk, and then they know the coordinates towards the Earth using pulsar stars. What those pulsar stars are, I will touch on later, but it's navigation if you want to do interstellar travel. But that's really, you know, already spacey and futuristic, so we'll start with a simple thing first. So we go to the next slide. So this is what this is an overview. Maybe it's more for the teachers, the overview. I will just first touch on how important the sun was for the navigation. Then later on, number 2, you will see that the Earth, stars, and planets also played a special role, especially for another way to coordinate our place on Earth. You will see latitude and longitude. I will explain you that later. Then when the satellites are being used from the 20th century, less than 100 years ago, then rockets and everything, and they could launch satellites into space. And we can use satellites for a GPS system, a global pointing system. It's to know not only where on Earth we are, but also how high we are. So the altitude will be added. And there's also an aspect of time, but I don't think that I will get into detail for that unless you have some question about it. And then a small thing about Mars Orbiter Laser Altimeter, also called MOLA, and why we are able to make 3D pins of, well, no, you cannot see it, of, for example, the Gale crater, but that's also part of navigation. And then at the end, for the space probes, once we are leaving the Earth, we cannot use the Earth and not the Sun. If it's interstellar, then we cannot use the Sun and the Earth to actually navigate, and we have to use other sources. One of the special things in the future will be navigation with pulsar stars. Okay, so the Sun. Some of these instruments you will recognize, like the sundial at the left side. The sundial is a magnificent device that can tell you the time. The only minor point of a sundial is you cannot use it at night, of course, because the sun is only during the day. Underneath the sundial, there's a very big device that is situated in China, in Dongfeng. It's a part near the Shaolin Temple. It's near to Luoyang. And I've been there as well because I made my thesis about astronomical instruments. And this instrument is from Guoshoujing. The names are not really important, but for those who want to know. And this is a shadow caster. Well, what is it doing? On the upper part of the tower, there's a small bar, and when the sun is shining through it during, well, the highest point of the day, during the day, it will cast a shadow of this bar on the ruler, which is a very long ruler, starting from our down view of the picture until the tower. And because it's such a big device, we can really accurately measure the highest point of the sun during the year at noon and the lowest point. So we will exactly know when the solstice will appear, so the summer and the winter solstice. Now, because of the way that the sun is actually in a different angle towards the observer during the year, we can also use these angles if we know at an exact date, if we have made a calendar, for instance, by using such device as the shadowcaster tower. We could make a calendar, and with this calendar, we can use it every year to use with another tool to navigate on the Earth, to know on which latitude we are. Now, to explain this, I'll just go and skip some slides. I think it's maybe important to understand what latitude is before we explain the instruments. Now, the Earth looks like a ball, you all know that, and you can see that there are some numbers on it. You have the equator, which divides the Earth in two parts, the northern part and the southern part, and you will also see that the numbers are counting upwards to the North Pole from 0 degrees to 90 degrees. So if we would make an angle with the equator and the North Pole, we have an angle of 90 degrees if we're on the North Pole. Now, in Belgium, for instance, where I am, it's about in the middle, a little bit more to the north, it's 51 degrees. So it would be between the 30 and the 60. Now, for people who are living in the south of the globe, they're counting downwards, so it's minus 30, minus 60, minus 90 degrees, but it's just the same way. Actually, it's a human invention for ourselves, so we can situate ourselves on the map if we are located somewhere on the Earth. But latitude is only in comparison with the equator, so it's between the pole and the equator that we can measure the distance. Later on, we will also try to measure in the other direction, It's the longitude. The longitude is a bit trickier. It took a longer time to sort out how they can manage to measure that accurately. But this is pretty much easy. And where you see the 90 degrees, not the minus 90 degrees because that's the South Pole, but the North Pole, that's also the axis where the Earth is spinning around. So if you could put a stick through the Earth, it will go through the 90 and the minus 90 degrees. Now, if you look at the stick at the 90 degrees and you would look up and you look at the small picture at the left, the axis actually pointing to a very famous star is the Polaris, is the polar star, and it's a very visible star. And a lot of navigators throughout the ages have used this star to actually pinpoint themselves on the Earth. Now, you can also see a word equinox and solstice. Well, I will explain solstice already because we touched upon it already. Solstice is actually the place of the sun in comparison with the horizon at its lowest point and its highest point. So it's actually what the shadowcaster is measuring. So if you have the highest point and the lowest point, then if you, for instance, at the equator, at 0 degrees, then if the highest point of the sun will be in the solstice will be not above 0. That's during the equinox. That's actually, if you see the word equinox, you have to try to look at the first 3 letters, like equator, equinox. So 0 degrees. If you're on the equator, then the equinox, that's during spring and autumn or fall. I don't know how you call it, but then the sun will be highest above you. Zenith is the highest point above your head. So if the horizon would be 0, then the highest point above your head would be 90 degrees. And so if you're living at the equator, for instance, Ecuador, if you look at the picture, I think it has its name from somewhere, then you can see that if you're at 0 degrees, then the sun will be, during the equinox, will be at the highest point, 90 degrees, zenith, and then it's its highest point. Now, during the solstice, it will be, the sun will be at its highest point between 2 latitude rings, which we will touch upon directly, and they are called the, well, we have the summer solstice and the winter solstice. So we have the latitude ring of Cancer and the latitude ring of Capricorn. Cancer is a more Latin name. If you don't know what Cancer is, it's not the illness, of course, but it's actually like a lobster or a crab. So I will first talk about these instruments. So here in the middle, you see the Amaryllis sphere, the device with all the rings, and maybe you can also already recognize some rings from the picture we saw earlier, but maybe it's still a bit confusing. But look at the picture of the astrolabe at the right-hand side, upper right-hand side. You can see that he's measuring the angle from the sun, this is the position of the sun. Mostly it's done at noon, and the highest position of the sun. And then where he's standing on the floor, and the floor is stretching towards the horizon. So we want an angle between the horizon and the sun. Now, the ancestor of the astrolabe and of the sextants, which you also will see in the picture at the right lower corner, in the right lower corner. If you don't know what I mean, just look at my webcam. It's this one, and this is actually used on boats later on, but astrolabe was first used. But it's difficult to use an astrolabe on a boat because you have to use a string, and if the boat is wiggling because of the waves, it's very difficult to use accurate measurements. Now, in the middle underneath, you will see a cross staff. it's actually the ancestor of, well, the sextant actually. How is it used? You can see on the picture that the man is holding a ruler with a movable piece, cross piece on it, and if it moves us closer to his eyes, the angle will get wider, and if it goes further away from his eyes, the angle towards the end tips of the plate and the ruler, so the end tips will make the angle smaller. And you have to aim the lower point of the plate or the cross stick, not the ruler, but the one that makes the angle. The lower part you have to aim at the horizon, and the upper part you have to aim at, for instance, the sun. So you can make a measurement and you know the angle. Later on, I will touch upon how to use these angles, of course. Here the astrolabe is a bit trickier. Here's some details of the astrolabe. I have one with me, but I have only one webcam. Well, I have 3 webcams, but I can only technically use one webcam on this webinar. But I hope you can see I have 2 parts. So you have in front you have a part with a ruler on it, which is movable, and you have also a part with all the stars on it, and behind you have all the coordinates that I will directly explain to you. And behind there is another ruler, but it's more an aimer. So if you look at the picture on the presentation at the right hand side, you will see that there is an indent. So it's like they made a small they take out a piece that's an indent, and you can use that to aim at a star, or if you use the sun, it may be better not to look at the sun, but to cast the shadow of the indent with the second indent, which is maybe not visible in the picture, but there are 2 indents, like wait, here and here. And so if you hold it like this, you can try to get the shadow of the both indents on a white sheet of paper or on the ground, if you're using the sun, of course. Now, how is an astrolabe? How do you have to look at it? Next to the title astrolabe, you will see that there are several rings. That's the flat image that you can look upon if you look at the front side of the astrolabe. So you see all the rings, and there are some parts that are not ringed, and there's a movable circle as well. Now, the mater is actually the entire device, the fixed device that you're holding, and the plate is actually the part underneath the movable part. Here's the movable part, but underneath there is a plate that you can change depending on which latitude you are. Then you have, you have to carry a lot of plates, but most of the plates, they are all from the northern hemisphere in that period, because astrolabes were especially used, well, in the beginning by Greeks, but then later on, the biggest usage of the astrolabe is by the Arabic countries. So they use the astrolabe, and there are a lot of things that you can see on the astrolabe. So if you look at the second picture on the presentation, you will see a circle, which is the Earth, and you see several rings. Now these rings, we already talked about a little bit if we talked about the sun angles. If you look at the blue ring, the upper ring of the middle picture, that's actually the point where the sun will shine highest. So when in zenith, it will be 90 degrees for the observer, and that's the circle of Cancer, or the crab, or the lobster. That's a special constellation of stars that we will deal with later, because otherwise it will be all at once. And then underneath you will see the black circle. Actually, it's the middle circle of the Earth. That's the equator. And then you have the red circle. The red circle is the outer circle on the, well, it's the lower point. Well, it's the highest point for the sun for the people who are living in the southern hemisphere, and the southern part of the Earth, I mean. and that's the circle of Capricorn. That's where the sun will be highest during, for us, it's during autumn, during fall. So, but for them, it's then, no, it's summer, sorry. So it's summer for the people in the southern hemisphere, but if the sun is highest above the red circle, then for us it's winter. So for us it will be summer if the sun will be highest above the blue circle, and the circle of Cancer. And in the middle is the equator, and when the sun is highest there, then we have fall or we have spring. Now, what happened with the astrolabe? Everything is flattened out. So we put all the rings together. Yeah. So the inner ring, if you look at the upper picture again, you will see a ring in the first yellow ring will be actually the Cancer circle, the circle for our summer solstice. And then we have the equator in blue. And then the outer circle is actually enlarged. If you look at the second picture, it's enlarged to in comparison with the inner circle of Cancer. So that's Capricorn. And so it's flattened out. And if you look at the last picture, then you will see that the zenith, the highest point for us, not the highest point of, well, not the North Pole axis, but the highest point where we are and the plate that we use at the moment. If you look at the picture, the middle point where everything is turning is actually the pole star. So if you see at the lower picture, you will see north will be in the middle. But the other circles, which are elongated, it's is in comparison to your highest point. So your highest point will be here. Well, for me, 51 degrees. I don't know if you see it on the webcam. It will be here somewhere. So in the middle. So you see, the reason why the polar star should be in the middle is because all the stars revolve around the middle. And because the Earth keeps on turning, and all the stars appear to turn. But actually it's not the stars that are turning, but actually the Earth is turning the opposite way. And the polar star is one point which is in the extension of the Earth axis in the north. Is going to be fixed in comparison with the other stars, which we can use as the middle point of the astrolabe. Now, maybe now I hope it's not too confusing, but it will all come together and will be more easy to look at it. Now, how to use it? In the first picture, you will see you aim the indent towards the star or the sun. If you use the sun, you cast a shadow on a sheet of paper on the ground. Don't look directly at it. And then, if you know the angle, you use the other part, so the front part of your disk. And if you use the sun, you put actually, in comparison with the date on the back there is a date. And you're going to look, there are some dates on it. Maybe it's not really visible here, but you can see it on the picture. There are some dates. And you align it with a date. And then you can see that there are some constellation names on it with a number on it. And then you can put the number, you use the middle part with all the constellations on it. This is actually the ecliptic, or the constellations where the sun appear in during the year. And you will you turn it, and then you put it on the highest point towards zenith, and then you see it's 12 o'clock. Of course, it's the highest point of the sun. But if you use the stars, then you do it differently. You use the same way. You look at the star, you put the angle, and you take the star and you put it on the right side or the left side, depending on if it's in the east or in the west. You can compare it with the polar star. If it's coming up, and then you take all the star names you can see here and a point here I will take as an example, easy example. It's, for example, Vega. Just see if it's here. Vega. You can see it on maybe on the picture as well. Vega, and then you just put it this way with the angle that was mentioned during the observation, and on the other side you will see what time it is. So actually, it gives you it gives you a lot of knowledge. It's not just looking at your iPhone and see, oh, it's like 4 hours or anything. No, you have a lot of work of it. Of course, normally it takes like 1 minute and then you know it. But you know, you have the orientation. You know where you are. You know where the stars are, how the sun is, or what you know, the calendar. You are actually one with the universe, and at the same time, you know what time it is. So this is a magnificent device. It's a bit like a computer, you know, only it is not electronically, of course. Now, all these rings, they will come together. So try to remember that if you look at the pictures and you see Leo and Virgo and Gemini, they are all constellations of the ecliptic. So I go to the next slide, and here you will see the other tool that is used on boats and which has no, well, the minor part of an astrolabe is that the waves of the boat could, you know, shake everything up. So you use this special device, and the special device, if you look at the picture underneath, normally it's an animation, but I cannot show it to you. But if you look at what you see through the mirror, I think it's the first picture, detailed picture. You can see a mirror, and it casts on a second half mirror. In the second half mirror, you can see a list of ancestor of cross staff, quadrant, sextant, octant. Underneath octant, there's a picture, and you can see there's a half mirror and there's an opening. So it's half open and half mirrored. Now the mirror is actually showing you a picture of the first mirror, which you see in the first picture on the right side. So the sun comes on the first mirror and then the second mirror, but it's only half visible. So in the middle picture, you can see it's half casted, so there's a sun on it, and you have to put the sun on the horizon with the left side. If you look at it, maybe I will just show it you. So here you can see a lot of things. You can use it with the sun. You can also, so you have different filters to protect your eyes here. So you can put it in front of the mirror. And you also have other telescopes. Like now there's no magnification, of course. Don't magnify the sun towards your eyes. Then you use another piece, which is a telescope, which gives you magnification if you're looking at stars at night. And then of course you don't need those filters unless those stars are very bright. But it's very ingenious because you just bring the horizon and the objects in the heavens together, and then you can read it. You can read the angle underneath, so you can read here the angle which you have. And so at noon, if you look at the highest point of the sun, you can know your position towards the Earth. And how do you know the position towards the Earth? Well, you look at it, and for instance, it's during, let's make it really simple, and let's say that it's spring. So during spring, the sun will be highest above the equator. Yeah? And if the sun is highest above the equator and you're on the North Pole, then, well, if you look at the sun will be on the horizon. So if you're on the North Pole, then it means that the sun has an angle 0 with the horizon. And so you have to add 90 degrees. So if you see equinox, you have to add 90 degrees to know what the angle is towards the Earth. And if you your angle is, for example, in my case, 51, but I don't know it, so I will see the sun at highest point during the equinox at 39 degrees. So if I add it up, then I have 90. So, well, it's a quick explanation of it. Of course, you're not going to use it right away, but so you can understand what latitude is and how you use these instruments to know how high the sun is in comparison to where you are on the Earth. Now, the second stage, bit easier to explain, but it's more advanced. Earth, stars, and planets. Why do I mention Earth? Because the Earth is turning around, of course, and we can know our position towards the pole and the equator, but we don't know our place towards another place, which is further away. So if you look at, you want to know, this is called longitude. If you look at the first picture, you see all the degrees here, and I have here a ball, and on it's an old orb, and on the orb you can see here, maybe you can see it in detail, I don't know, but here it's from 1, and you can turn it, it's from 1 to 24. So actually you can indicate the hours, and every 15 degrees is 1 hour. If you already learned some angles, you know that a circle is 360, and if you divide it to 24, you will have 15 degrees. And it's also mentioned on the first picture. You can see 0, 15, 30, 45, 60. So how it's easy to explain? For instance, if we use the 0 point of longitude, which is in the United Kingdom and England, in Greenwich, is 0. And for instance, if we look at a watch that we have and we see the watch of Greenwich tells now it's like 4 in the afternoon, and it's noon at your place because the angle of the sun, the highest point of the sun is now, so it's noon for you. But there's like with your clock, it's 12, but it's 4 o'clock in England. So you know you have to subtract if you are in the west. And you can subtract 4 times 15 degrees. So if you go 15, 30, 45, you're like 60 degrees towards the west. Now that's one thing, that's the longitude. But if you remember the pole star, so you can see the North Star, you can also see a constellation which you already learned, perhaps. It's the Big Dipper. It's a big bear, and we call it Big Dipper. But if you look at the picture in the middle, it's not the entire Big Dipper. It's just a pan. We call it a frying pan, but the Chinese, they call it the spoon, and later on you will see why they call it the spoon. And if you see that the pan, not the handle, but if you look where they state fall, where there's fall, the name fall on it. So underneath the under constellation of the Big Dipper, if you follow both stars towards the north like 5 times, then you come to the North Star. So it's also easy to find the North Star if you're not really, like, it's not the most visible star in the night sky, the North Star. So sometimes you want to use other constellations to find the North Star to know where the north is. Okay, then we also have like Jupiter. And that's a funny thing, we can use Jupiter as a universal clock. Now longitude, I just explained it, as in the other side. So you go from 0 all around to 180 or to the other side. Normally, most of the time they just count from 0 to 360 around, starting from left to right. And I already said that 360 degrees divided to 24 hours, then you have like 15 degrees per 1 hour. And you can, for instance, compare noon at Greenwich with noon at the location where you are. You can also use an almanac with all the stars. And Jupiter and moons, that's really interesting. That's what I'm going to show you directly. Jupiter has several moons, and so, but it's later stage when they already invented telescopes, of course, and you can see like where the positions of the moons are, because where the positions of the moons are in Greenwich or some other part at the world at a certain time, it's always going to be the same. So you know what time it is in the almanac of a certain place, and you can just use it as a clock and compare where you are on the Earth. So that's a way, but it's pretty difficult on a ship because you're moving all the time on the waves, and that's going to be nasty with a telescope. If you used the telescope before, you know what I mean. So then I see that I have to hurry up because I talk a lot. I'm going backwards, of course, so you already know where it's coming. Now, about the compass, it's really cool. If you have seen, maybe you know that Chinese invented the compass, and they used like a lodestone, and lodestone is magnetized stone. And if you look at the spoon is also called a south pointer. Even today, the compasses are called by Chinese a south pointer. And if you look at the handle will point towards the south, and the spoon will point towards the north. And they compare the spoon with the Big Dipper. So it's really handy because the two stars of the spoon, they are pointing towards the polar star, to polarize. Now, there is also another kind of variation with magnetic field. There's a difference between the Earth axis and the magnetic pole, but that's really difficult to measure. So that was not the solution. So later on, they invented the sea clock. Now, stars axis. I'm not going to touch on this because maybe it's more complicated. Unless you have a question on it, then I will explain this because I will be running out of time. That's why I'm going a bit quicker. Now, there's a difference between the equator and the plane of the moon. If you look at the first picture, you see the moon is going around the Earth, but there's a difference between the equator and the moon. So it's just a little thing that you have to know. The moon is not exactly revolving above the equator of the Earth. And you can also see Earth's orbit around the Sun, so you will see that there is a tilt of 23.5 degrees, but I think it's not really suitable for the younger kids to know that already. Now, this is a special device that I just want to show you. It's a very ancient device, and it's the forefather of a telescope. And so you can measure the positions of the stars with an armillary sphere. The first picture is a Chinese armillary sphere, and the middle part is actually I think it's Arabic armillary sphere. And then you see a Chinese combination of a astrolabe and the equatorial mount, which is, if you see it, it's a bit in an angle towards the polar star. Now, if you look at the names, Kublai Khan is a really famous ruler that ruled big part of the world, China. Well, the Mongolian Empire was really vast. Kublai Khan controlled China and Mongolia, and he also praised other cultures come together. And thanks to this multicultural thing that Kublai Khan really liked to get a knowledge of, you will see the name Jamaldin and Guo Shujing, and they both come together and they worked for Kublai Khan to measure the stars and the seasons, because a very good ruler knows the seasons and know how the crops must grow and everything. So for the food for the population, of course. But what has happened with this device? Look at this device in the middle. That's a simplified device, and it's a forerunner of the equatorial mount that is being used for telescopes today. So the telescope behind me still has this equatorial mount. And if you see one part at the left, you can see it's an astrolabe. You know, it's an astrolabe, and you have the equatorial mount. And the astrolabe it's what the Islam culture, or the Arabic countries used, and Jamaldin was from Kanate. It's a part of the Mongolian part, which is situated in the Middle East, which is called Persia later, and it was used together with the axis, which is pointed to the polar star. So now it's loose together. It's easy. It's much easier. So you know how high a star is towards the horizon for your angling, to know which angle with the horizon a star has. But you also have like a fixed position towards the poles, the celestial poles. So you just have to turn one axis and not both axes for following certain objects, and that is done with the second part. I'm not going to in detail because I can talk for a day only about this device. But it's just to show you that it's really a great device to talk about. If you look at the star chart, I make it a bit simple. It's flattened, of course. Normally it should be like an orb. If you look at the sky, you will see at the upper hand, you will see the Big Dipper. And then underneath you will see like the Southern Cross. And if you use a Southern Cross with 2 stars of Centaur, you can combine it and find a fixed point which is an extension of the Southern axis. But that's much later used when they use navigation in the southern hemisphere of the Earth. And there are a lot of stars on it. You will see the zodiac. The yellow route is where the sun is shining. And every time it's like you see the white dots, it's every month it's shining in another constellation. Sometimes you will see some other constellations like Gemini, so from the zodiac. And even there are more than 12 constellations. There is even the 13th constellation. If in the green, you can see that the snake bearer of Pythias. Actually, there are 13 zodiac constellations instead of 12. If you have any questions on that, you can ask me later. I can show you about how they are shifted and everything. Now, about the satellites. Satellites are also very important. Nowadays, we use satellites. It's very handy. If you can have like 3 satellites, it can give you the longitude and the latitude. And not only this, if you have a device at home like GPS, or your father or mother has one in the car, it's also always important to have at least 3 connections with satellites, so it can give you a fixed position in latitude, longitude, and even altitude. So if you look at the screen at the right-hand side, you will see all these numbers. They give you where exactly you are. But of course, there are more than 3 satellites. Most of the time, there will be like 10 or 11 satellites visible to you at the same time. Another thing is what you can do with satellites. If you're around an other planet, or even Earth as well, you can even measure the height using a special laser. The laser goes down towards the planet and bounces back up, and the time it takes to bounce back up gives you actually how high something is. So the faster it's up, the higher a certain region is, and the lower it takes for the laser to bounce back up towards the satellite, the deeper it is. So you can make an altitude map. So that's pretty neat. Now with space probes, if you followed the New Horizon adventure last year, going to Pluto, and you can see in the first picture there's a man sitting and walking at the star tracker. It has 2 modules, and one of these modules you will see on the right-hand side, and it makes pictures of constellations. And this is really handy because if you have a database and you know your orientation towards the Earth with all the constellations and how your probe is going, but you don't have satellites to guide them because the satellites are only around the Earth, then at least you can use the stars again. You see, the GPS is not a solution for everything. So if you're going outside the Earth system, then you have to use a star tracker for positioning for space probes. Another thing is one of the space probes from the 70s is called Voyager. We have the 1 and the 2, and this Voyager is really neat. Now, to give a quick impression of what the Voyager does, I'm going to show you a small something. I hope it's going to work like this, and I'm hoping it's going to work this way. Okay, there's a quick to show you how the Voyager goes. The model of the Voyager is like this. So I hope you will all be able to see what I'm showing you at this moment. This is the Voyager. I also have a small toy of it, if you call it that way, a model. I turn it around and you will see a disk on it. And this disk, there's also a telescope and some communication device. But the disk is really interesting, but because the disk has something special on it. And the special thing about the disk, I'm going to show you in a moment. after I show you what the probe has done. The probe has done several things. A quick overview of what the Voyager 2 has done. It has passed Earth, passed Mars, and then now it is going to Jupiter. You will see the year above when it passes Jupiter. It gets a slingshot. Now Jupiter is going to attract the probe and going to give extra slingshot. Why is the slingshot there? Because attracting, it means it falls towards towards Jupiter, but it falls right next to Jupiter. Otherwise, it will explode or just vanish into Jupiter. So it just measured that it just passes by Jupiter. It gets slingshot to Saturn to make some more pictures, and then it goes to the other two. So it's really difficult to get these positions right, and in the 70s we had all the planets lined in a way that we could. Nowadays it will be more difficult to get the right lineup, so they had to do it in the 70s. And then you can see there is Neptune. I don't know if I can speed it up. Yeah, you have here Uranus, and then you have Neptune, and then it vanishes. Now, what is the neat thing about this disk? You will see that there is there are some of the pictures on it. Most of the icons on it is just how to use the disk, because there is a lot of greetings in a lot of languages: Chinese, Arabic, Italian, all languages. I think in more than 100 languages. There are some greetings, some music from the 60s. All that is just a sort of legacy of humankind that they put on this probe. But underneath there we will see that there is like a star, but it's not a star. The middle of the star is actually the position of the sun, and our sun in comparison of other stars, and that are not really live stars. Those stars already died out. They already exploded into the supernova, but they're so heavy that they actually also have a rotation axis, but the rotation axis is sometimes turning towards us and flashing. That's why they're called pulsars. But they are so flashing in a regular fashion that there's a special rhythm, and this rhythm is like a sort of code, and every pulsar has a different code. And if you have all unique pulsars and you map them out towards the position where you are, then you have another kind of navigation system. I think it is really, really neat how they could use special stars for position if we go to other stars. But of course, when humans go to other stars, it's a bit science fiction. But already they put it in the 70s. They already put this kind of navigation or mapping of where the sun is, the solar system, on this little disk on the Voyager. Now, to finish up, I'm going to wrap up everything. I'm going to show you what is actually behind me. It's actually an armillary sphere with a magnification. It's just like a lens or a mirror. It could be magnifying both. You had Van Monckhoven is the name of the telescope behind me, because that's the person who purchased it. And he wanted to map the sky and make pictures of it, because in the 19th century photography started to boom, and he wanted to make pictures of the entire sky. But he never succeeded, because he died before the telescope was finished, but later the university used it. Then I will just skip this one. So here you see two kinds of telescopes. At the upper corner you have the lens telescope, and the thick one, the bigger one, is a self-made telescope, but not mine. And there's a mirror telescope. So if you look at that's maybe a bit confusing, the picture underneath, but you can see that there is a mirror with blue stripes reflecting the light to your eyepiece to give you a magnification. And then you have a lens which is not reflecting the light, but it's just bending the light, and just like binoculars or magnifying glass, you can see your magnification through the eyepiece behind it. Then there is also a big difference between a night watcher and a day watcher. most of you know night watchers. You look at the stars with a telescope. But a day watcher is actually a telescope which is actually observing the sun. Sometimes it's very interesting to see sunspots or like little flames around the sun. They are not really flames, they are just prominences. It's a difficult word to modern word to explain gas eruptions around the sun. And you can also see sometimes a small planet passing in front of the sun, which is a transit. For example, Mercury transit, which was a couple of months ago. And then we also have Venus transits, which are very rare, but are also easy to look at with a day watcher. The star clock, I think I'm going to leave it like this because I think this might be a bit confusing. If you have a question about the star clock, I will answer it. And the parallax, in general, the sextant, what we saw, or the astrolabe, using angles, what we're now doing these days to see how far a star is or how far planets are, is actually by using the telescope as a very big sextant. So we put telescopes on different places on the Earth, and we compare, for instance, where Venus is on the Sun, and we can measure with special calculations how far the Sun is from the Earth. And because we know of the periods of the orbits of all the other planets, how the comparison in percentages towards the Earth, then once we know exact measurements in kilometers, we can do everything in kilometers with all the other planets. So that's a huge invention or usage that they applied while using telescopes with angles. The same is how far stars are. They also use angles, and then the Earth is used actually like a sextant. So you have to wait a half a year. So in January you make an observation, and in July you make an observation. And it's not animated here, but the two big spot stars underneath will be shifted, and then you can measure the angle. And thanks to angle measurements, you know how far a star is. That's all thanks to the invention of astrolabes, armillary spheres, and of course sextants and crossstaff and all those things. Spectroscopy is not what I'm going to explain. It's maybe a bit difficult to explain, but if you have a question on it, I just put it in because it's also used for measurements and to know what kind of substance is in a star or on planets. But it's just all these parts are present on the telescope. So this is a lens telescope, a solar telescope, equatorial mount. It has a guiding system with weights. So it's pulling, so it can turn around the axis which is pointing to the polar star. And it also has prisms to make rainbows of the light that you are capturing, to decode the light and know what stars are made of. So here you see some details.
Vincent, thank you very much. Sorry to cut it short. We've had an hour now, and we started getting a lot of questions from the participants.
Yes.
So maybe I could start with the first one, and this is very specific.
Yes.
And
okay.
someone here asked us the application that they saw for the Voyager trajectory. Is that available for download?
You mean the animation?
Yes, I believe so.
Yeah, that's available for download. Well, one thing that you can use is called NASA's EYES. It's I don't know, maybe.
Can you type that in the chat?
Yes, I
and
can.
send to everyone so that participants can see.
Wait. So I have to, because how can I choose all? Everyone. Okay.
Exactly.
So it's called. You just have to type it as NASA's EYES. It's not the one that I showed, but if you want the one that I showed, I can give it to you, for instance, and you can make it available, or can make the link available through email or whatever on a forum.
Okay.
Because it's actually something that we made ourselves. So it's a
Oh,
program that we made ourselves, but they can use it. It's free of you. You can use it. There's a lot of stuff that can use stars and planets. Everything is on it, so you can use
okay,
it as well.
great. Then we will share this with the participants after we're done with the webinar.
Yes.
Okay. Now let's see, another question here. It's interesting to notice that several instruments were invented by different civilizations in different ages, but used and perfected by others according to their goals and objectives. So do you think that this is still the case today?
So you mean the different inventions are linked to their cultures or their needs? Is that what the question is? I do think it. Well, to give you an example.
Yes, that's the question.
To give you an example, if you look at the 20th century and you look at the space race, the space race was not going to, it's not for scientific use. It was it's the Cold War. It's just a situation to actually control entire space. If you can control space, you are a big ruler. So it was everything is actually shaped towards politics, about culture as well. What kind of belief you have. For instance, astrolabes are also used for their beliefs, to orientate themselves for praying and everything. So I think yes, it's still like this. Now we are living in a world which became smaller because of our communication. So everything is intertwined now. So it's less the case than when the world was bigger and everyone was living separately. But still, all different inputs of different culture working together. If you look at big scientific organizations, their input is always, of course, linked with their education and their culture.
Okay, great, thank you. Now you mentioned this combination of culture, and from what we could see in your presentation, it's clear that this topic that you talked about, teachers can breach this topic in any subject, so from history to geography, even politics, and so on. Is there anything you recommend to teachers who are teaching these topics and who maybe also are dealing with a lot of cultural diversity in their classrooms?
Yes, always try to mention where things are coming from. Because to give you of course, a history lesson is of course a good indicator to if this is really specific, like the simplified instrument of Jing, which is being invented thanks to the cultural mix that was present of Arabic astronomy as well. But later on, you will see that in science, science is like a human pursuit, another a cultural pursuit. So you will see that different cultures, they will gather together to make their curiosity at ease. They really want to discover a lot of stuff. And what is important in class is, for instance, try if you're teaching something. You can say the numbers and the facts, but also try to say how it came to be that we know these things. You start from something simple to something complex, because if you just give the numbers of something complex, for example, how a rocket flies and everything, what all the satellites can do, but not where it came from, it's going to be difficult. Obviously, teachers will have more time to touch on this than I have. I have to compress everything, but I think we don't want a society that, for instance, doesn't believe in the moon landings because they cannot see, for instance, past the fact that a lot of inventions, thanks to the space exploration, has been invented. Like, for example, X-rays, micro oven, even instant soup, for the astronauts and everything. In the 70s, it was really, everything was instant. It was thanks to the space race and everything was in. And also all the smartphones you have, it's not just, it doesn't appear that magically. You know, this device, it comes from somewhere, and it also has the GPS on it, communication, everything, and it's all because of developing and working together with several nations to acquire this knowledge. Sometimes it's weird to see that it's not a cooperation, but it's just a competition sometimes between Russia and America. But still, it's in some weird way they are engaging and working together to reach that goal.
That's great. Yeah, thank you for that, Vincent. So you mentioned a lot of things about how these instruments and how space sciences have evolved in time and how they impact us today. But how do you think all of this will look in the following years? Do you have any idea of how these things will impact our daily life in the future?
You mean navigation as a whole? It already impacts our daily life. You know, if you're driving to a party, you use your GPS system in your car. It's just it's just like having clothing. It's so people cannot miss it anymore. Like if you look at 20 years ago, well, GPS system, you have a GPS system in your car. Wow, it's something special. But the children who grow up now, GPS system and smartphones are just everyday use. They will be astonished if they look at a phone of 50 years ago, 60 years ago, which still has this disc on it, which you have to turn around. They say how to use it, where to press our buttons, because it's really weird. But try to know where they came from and how everything developed, because now we compress all the knowledges, and we have to be careful that we don't lose this, because by compressing all the knowledge using computers, because they can do some certain stuff, we don't have to use things by like in comparison to former educations, we don't have to use by memory a lot of stuff, because we can just look it up. So we have a different way of thinking. We can concentrate ourselves to managing all the data that we have instead of remembering all the data. And so we are going to develop in a society where even all the data will be connected directly perhaps in your mind, because now it's in your pocket, but maybe in the future it will be just be imprinted in your mind, and you can, maybe we don't talk anymore, we just telepathically converse with each other through internet. Maybe that's the case if you see how fast everything develops.
Or if you look at science fiction movies, then it's already something that some people have been thinking about.
But if you look at all the inventions, then if you look at inventions of the 20th century, a lot of inventions, they come from science fiction, because the inventor, they looked at the science fiction and said, oh, maybe that's possible, let's invent it.
Okay, very cool insight, thank you. And now 2 more questions that we've had here in the chat, and with that we will end our first Space Awareness webinar. So one of the 2 questions is regarding the instruments. So someone here said that they look very beautiful, and they're interested to know, what is the oldest astronomical instrument you have at the observatory?
Well, the instruments that I showed you are from my private collection, because I'm really into it. Of course, the telescope is not my private collection, it's from the observatory. But there are a lot of astronomical devices that we have locked away and that we want to showcase one day, like sextants and special instruments that are part of the telescope. And a lot of ancient devices can be seen at our campus if you visit Ghent. In the university, there's a museum with all of these gadgets. But of course, the globe is not mine, but the armilosphere and the astrolabe, I especially brought it here to explain it to you and to make some pictures and to make it a bit more clear if you wanted to. But there are replicas, and most of these replicas you can just buy online. And to have one of these replicas in the classroom is always a must, because you can just show you, if you really try to find out how it works and you show it at the children, they will be amazed on how simple but how complex measurements you can do with a simple instrument or invention just by thinking logically.
Okay, great. Thank you. And now another last question about the astrolabe. Could you tell us who invented it, and
Who?
if it's still used to navigate the seas now?
No, it's not for navigation on the seas. I already told you that it's really impractical on the seas because of the waves, and you just hold it with a string here, and if the waves are going this way, so it's easier to use a a cross staff or a kamal, or this is with a string and a plate, or your sextant. Sextant is specially invented to measure without the effect of the waves. Just the same with the sea clock, because the pendulum also has a problem with it. Now, the invention of the astrolabe, the oldest that they can find, and it's already rusted because it's I think it's from copper, so it will be green. The oldest ones can be found in Greece, I think. But the most inheritant ones, like ancient ones that are still in possession of families, are like a lot of Arabic cultures. They have it still. Like some prestigious families, they still have like old astrolabes from ancestors and before. They will still have the old stuff. But nowadays it will not be used because we have satellites and everything, so we don't use it. We just, but it's interesting to know what the basic is of orientation towards the Earth and the stars.
Okay, great. Thank you very much. And with this, we're going to wrap up this webinar. Thank you very, very much, Vincent, for this talk and for taking the time to tell us about everything. Now, two mentions on our side from the Space Awareness Project. We are now working to develop a hands-on kit called the Islamic Heritage Kit, which highlights the contribution of Islamic scientists to the progress of astronomy. So it also touches upon a lot of the topics that Vincent mentioned. And one of the resources will be to develop an astrolabe. So this will be soon available for teachers. And also, if you look in the chat, you will see there a link to some educational resources on navigation for primary school children, which are already available in the Space Awareness website. So for those of you who are teachers or who are working in the area of teaching about navigation, you can follow that link and discover more resources.
Okay.
Yes, Vincent, please.
Yeah, I see that there is a lot of chatting going on. Do I have to stay and answer some of these? Or,
basically, you can look. Basically, people are thanking you, and they were saying that it was very interesting and complete. So congratulations for that.
Yeah, I hope it wasn't too much. So.
No worries. But for anyone who has missed any part of it, we have a recording. So this will be available on the Space Awareness website. We will send everyone an email after the end of the webinar, and once the recording is up and running on the website, so you can always go back and rewatch or use it if you want to use it with if you want to use this webinar with your students and so on. So that's about it. Thank you to everyone who has participated. Thank you, Vincent, again for taking the time and for showing us all of the cool instruments that you have at your disposal and for sharing of your knowledge. And if you're curious about the project, you can follow us on the website and social media, so feel free to get in touch with us. And we'll keep you posted with more updates on next webinars. Thank you very much, and goodbye, everyone.
Perfect. Welcome.